Welcome back to the channel, and I know a few of you guys are interested to know what exactly went wrong with the 4,000 kilometer rebuild. So I'm here at Raceonly, and Omar has very generously offered his time to show us what went wrong and also to show us what we're going to do next. So let's go inside and meet Omar.
I wanna be the best in the game, invest in my name, check no restraints, I'm obsessed with the pain. I ingest, I retain, assess and I change, possessed by the thought I'll be free one day from society's restraints, money, clout and fame, a disease of plague. We all love to hate, have to play the game, have to make a name, all our insecurities are on this is war with the enemy.
Alright, I'm here with Omar at Raceonly, and I actually don't know Omar heaps well. You know, I've actually met him twice. The first time I met him at Rotor's Bunnings, but he doesn't remember me.
No, I don't.
So,
that's really bad, right?
And the last time was just earlier this week. So I'm going to start off with three kind of icebreaker questions. You know, we're going to break in this relationship.
Let's do it.
Yeah. So first one, have you been vaccinated?
I have, yes.
Yep. Pfizer or AstraZeneca?
Pfizer.
Oh, American.
Hey, I got bullied into it by my dad, so I'm just going to blame it on him.
Yeah. Okay. Circuit or drag racing, and why?
Okay. That's actually a trick question. If you had asked me a couple of years ago, I would have just said drag racing and circuit wouldn't come up at all. Only because that's what got me into rotaries in the first place.
Ah, okay.
My first time ever seeing a rotary, I went to Eastern Creek and I saw a car. I used to have the plates gas and go, and it had a 20B in it, did a massive wheel stand, and I was just like,
how long ago was this?
This was 2002.
Wow.
Or maybe, no, wait, 2001.
I was under 10.
2001, I'm pretty sure.
I was 8.
I remember seeing this car and I was just like, I need to have me one of those.
Yeah.
Funnily enough, this whole workshop, everything started from that.
Oh, okay.
Believe it or not, that was the beginning of it all. So, but I am kind of venturing into the world of circuit racing. I want to build a time attack car.
Good answer.
And that is coming.
That's good.
Yeah.
More about the shop later.
Yeah.
If the world ran out of 13Bs, just hypothetically, would you K-swap it or would you LS swap it?
K-swap.
K-swap.
All day long.
Good answer.
Yeah, we can blame that on Norman. He infected me with Honda.
Yeah, we were just talking about it actually. But yeah, great choice.
He infected me with Honda.
Okay, so you guys have been here for a while. Tell me a bit about racing. What do you guys do?
Okay, so we're a rotary only shop. We don't do any other type of car. It has to be rotary. We would walk through the shop. We mainly focus on a couple of platforms. FD, obviously. We do lots of FCs as well, and RX-8. Yes, we do get the odd RX2 or RX3, but it's not really our specialty.
So what would you say, what is your main platform?
FD. FD is our main platform. Again, I've kind of ventured into a few other platforms and we're still learning in those platforms, but FD,
it's always where it's going to be at.
Correct. It was my first rotary love, if you like. I don't know, I guess it's hard to explain, but the first time I saw an FD, you just know you just want one.
Yeah.
I tried buying one a couple of times, and just like most other guys, like when I bought my first FD, I pretty much shelled out everything together. It was my life savings and everything else.
Yeah.
No regrets, obviously. So,
awesome.
Raceonly is 100% rotary only. We do engine building, we do tuning, we do wiring. Obviously, we do mechanical work, and we do some fabrication as well. I wouldn't go as far as say the full one-stop shop, but we do most things.
Yeah, that's great.
We try to do as much as we can ourselves, I guess, so we try and keep accountable for most of the stuff that we do, and it means we get to quality control all the stuff that we do as well, because that's really important in this industry, is trying to make sure your stuff is quality and make sure that you can have some sort of accountability for it as well.
Yeah, awesome. So, great. So while we're talking about engine building, Omar's actually taken apart my engine already, and it doesn't look too good. So he's actually invited us down just to have a look to see what's going on with it and to see what we're going to do from there. So,
all right. So we have our rear iron here. Now, I guess I don't know if you've mentioned it, but this engine leaked coolant in the rear rotor.
Rear rotor.
Okay.
Yeah.
So I mean, common sense would tell you, let's look at the rear rotor in depth and see if we can find a reason, I guess, for the leak, if you like. I don't know if you can really see them. I guess you might be able to get some close-ups a bit later. But I've texted out some areas, okay, where there's material missing off the water jacket. So I probably should explain, water seals normally sit inside these grooves. You ideally want this groove to be in good condition. So, and that applies to both sides, so both this side and this side.
Yeah.
While this isn't broken right now, I wouldn't say that this would be the cause of our water leak. I would say this would be a reason not to want to use the iron, but I don't think that those actually caused our leak.
Sure.
So, I mean, looking at this plate, we can't really see anything that steps out and says this was your coolant leak.
Would you say that the cause of the leak would be the seal itself?
So it can be the seal, okay? So this particular engine had aftermarket coolant seals, didn't have OEMs. Now, we couldn't see anything wrong with the coolant seals themselves. There wasn't any breakages, there wasn't anything to indicate that they had failed. But in my experience over the years, I've always found aftermarket water seals aren't as tolerant as the OEM seal. They're not as rugged. I've seen some OEM water seal engines really put up with some really high temps and still come out with no leak. It's hard to say. I guess once we have a look at the rotor housing will tell us a bit more of a story.
Let's have a look at the
rotor housing. Let's do that. So I'm going to swap that out. All right. So Mazda give us a couple of points, obviously, to check for warpage. So we want to see if the housing is still straight or not. So they ask us to measure the rotor housing up the top here, and they ask us to measure the rotor housing at 3 points here. And what we're looking for is we're looking for a difference between the top and this section here. So Mazda specification is 0.06 millimeters. So if we're on that or above that, then this housing would be considered not usable. If we're below that, then we're okay. So basically, I'm just going to slide this over our point. Now, if you're ever curious about what that point of measurement is, it's well documented in the factory manual. It's not top secret or anything like that. This isn't something that I came up with. This is just a factory manual process, okay? So we've got a number here of 80.008, okay? So let's just put that number down for a second and let's do our other measurements. So again, I'm just using Mazda's measuring points. So I'm just going to slide our measuring tool, make sure it's nice and square. Okay, so I've now got 80.014, okay? So basically what I got to do is I got to take 3 measurements and we got to look for the largest difference between this number and that number.
Sure.
Okay, so I'm going to take another measurement, 80.009, okay? 80.015, okay? So if we take the highest number, for example, so basically we're looking for the number that's furthest away from the top one. We've got basically
the largest difference between
we've got less than so pretty much we've got less than 0.01 millimeter difference between the top and the corner.
And that's a good one, isn't it?
And that's a good one. Good. Okay, so that's what a good rotor housing should look like. Okay, so I'm going to take this one away and we're going to look at this one.
This is the rear housing.
This is the rear. So this is where we had the coolant leak. So we haven't found anything wrong with the water jackets. So we're kind of hoping that when we take this measurement, there will be a problem. Because like I said to you before, the worst thing about pulling an engine apart is not finding an issue. Okay, so I've got 80.006, which is pretty close to the other rotor housing. So that's good. Okay, so I mean, you can already see, I haven't really dialed it down yet. But you can see that, right?
Yeah.
Okay, so straight away we've got 79.977. Okay, so we've already got quite a difference there. So this is where it gets really interesting. So you can see, I don't know if you can see that, we've got now one the other way.
Yeah.
Okay, we've got like a really high spot there for whatever reason. Okay, so whenever I measure a rotor housing and I see lots of movement around this area, you tend to find that there's an issue with this rotor housing. Yeah. So heat's obviously affected the rotor housing, and you've got lots of movement there. Okay, so you've got
is that a common area for it to be affected around the spark plug hole?
Look, it's interesting that Mazda picked this area as the part that you need to check for warpage. I would think that there's a reason for that, and I would say it's not a coincidence that it's near the spark plug hole, because this is the hottest part of the rotor housing. To me, this would be the area that would be mostly affected. So again, as you can see, as I move around, this area is really
it's definitely moving quite a bit.
There's quite a lot of volatility in this area. So we've got 79.975. Like we've basically measured anything between 80.05 and 79.97 in the space of 3 centimeters.
So what kind of variance are you happy with?
Okay,
as an engine builder?
So look, as an engine builder, I like to see less than 0.02, okay? And I like to see consistency. Theoretically, if we said, and this is like our conversation before, if we purely applied Mazda standard, we would probably be just under Mazda's 0.06, right? Okay, but to me, fitting a borderline part is very risky in itself. I mean, you pull the engine out yourself, it's a ton of work, right? And then stripping the engine down, putting it back together, it's an expensive process. You really only want to build the engine once. So to me, anything that strikes as borderline, you simply wouldn't use. And anything that shows that much inconsistency in a small area is going to leak. A set of rotor housings, assuming they aren't, overheated, should last 20, 25 years. And there's no reason why they shouldn't last that long. Okay, it's not something that you should have to replace that often. Obviously, look, with really high performance engine, and this applies to any engine, when you push something really hard, the life changes. But I mean, this engine didn't really make a ton of power. It wasn't being really pushed very hard. So there's no reason why it shouldn't last a very long time. Obviously, we've looked at the rear rotor housing and the rear plate, and we focused on those because that's where the water leak was. But that doesn't mean that we just assume the front parts are good. I've kind of highlighted these areas here. Looking at these areas, it's probably hard to see in the camera, but there's lots of corrosion on this edge, okay? All these edges have a large amount of corrosion, and they are really thin. So if you compare it to this water jacket here, you can see how thick that is. You can see there's a lot of material that's gone from these areas. While the engine may work now, may not work later. So this is one of those irons that hasn't necessarily failed right now, but this is going to be an issue later on. Correct. Yep. So again, we don't build an engine so that we're only going to be using it for the next 12 months. We build it so that it can last for as long as possible, ideally for the life of that owner's. Yeah. There's also a couple of other things that we noticed on these irons that kind of make them less than ideal to use. When they did the porting on this engine, I don't know if you can see the lines. Yeah. They've used like a scriber mark or something like that to mark out the ports, and they actually mark the plates when they did it. I'm not sure why that is the case, but again, with any sort of wearing surface, you want as little marks as possible, especially ones that you can actually feel. I think the rear iron's actually got it worse than that. So definitely front and rear iron on this engine, we won't be using. Yeah. So what are the plans for the new engine? So I mean, obviously we're going to be replacing front and rear iron. We're going to be replacing a rotor housing, and everything else we're going to reuse. So we're reusing crank rotors. The rotors are here. So what are we doing to this engine to make it, I guess, more powerful, if you like, and be able to handle more power itself, because they're both different things, right? So we're obviously going to be porting the engine. So I'm just going to slide these this way. So on a rotary engine, this is your power, if you like. All the power you're going to make is going to be via this hole. So basically, we're doing a bridge port, okay, because you want the braps. So bridge port has two things about it. So a bridge port is like a main port plus the bridge. So basically, we cut an additional hole right next to the water jacket over here, okay, and you get left with a little bridge in the middle. That's why it's called a bridge port. We also port this main port as well. We don't really change the opening time so much. We change the closing time, which is basically the top of the port. That gives you a bit of extra top end without so much overlap. But again, a bridge port will have lots of overlap anyways. Okay, so as far as making more power, that's what we're going to do to make the engine make more power. And I know it doesn't sound like much, but believe it or not, the little changes that we make here will add an easy 100 horsepower with nothing else touched.
It sounds a lot better too.
Yeah. Lots of people will argue that. You'll be surprised how many bridge ports we do in the shop, and I get a visit maybe a month later to say, can we take it back? I'm like, yep, you definitely can't take that back. So yes, so as far as making more power is concerned, we'll be doing some porting there. Now, obviously because we're only changing one rotor housing, we'll need to match port between the old one and the new one. And on the old rotor housing, they've already done some porting in there, which is relatively okay. There's no issues with that. So we'll be using that template to make sure they're both matched. Now, so that's making more power, okay? So the next thing we're going to do is obviously we want to try and see if we can make the engine a little stronger, future-proof it if you like, because at the end of the day, again, like we said, we only want to build this engine once. So we want to try and make sure we get all the little things kind of wrapped up if you like. So the first thing I'm going to do is I'm going to grab some rotors. So I'm just going to slide this over. All right, so we've got both your rotors out of your current engine. So we're going to be doing some machining on the rotors to, I guess, prep them for future horsepower goals. Where you never know.
Hold me back.
Right? Look, you'll be surprised as to how many engines we do where guys will be like, nah, we're definitely not making over 400 horsepower. And then 6 months later, they're like, how much is it for twin pumps and E85?
And that's not going to be me.
Yeah, well, we'll see about that. So we like to make sure we want to build the engine so that it can handle all of those extra goals. Last thing we want to do is have to pull the engine down and add these things in later. We do something called side clearancing. Now, funnily enough, Mazda actually had already done their own version of this. Obviously, they felt that there was a need for it. We kind of take that and go a little further, but you can kind of see on the side of the rotor there's this little step. So Mazda have already taken quite a bit of material off the corners. Now we'll obviously take that a little further, and we usually do the whole face. Okay, it's just makes it a little easier to machine. It also looks a little better, and we also lose a little weight as well. And
how much kind of difference do you machine off the surface?
Okay, so we take another 0.2 mil past what Mazda does. Okay. Like we'll see roughly 100 grams per rotor on that sort of machine work. Okay, 100 grams is pretty good in a rotating assembly. Okay, and these will obviously be balanced after the machine. We also do some clearancing on the face of the rotor. So basically, a common failure point for these is this area here likes to touch the rotor housing. So we also remove some material out of the center section. Now, on an FD rotor, we don't like removing material out of these areas because they're quite thin. And they're already renowned for basically caving in this area when something goes wrong. So we try to keep this area as thick as possible and not really muck with it too much. As far as rotor machining is, that's pretty much it. Now, you can do things like rotor lightning and stuff like that. Again, that's not for everyone, and some people kind of want the best of everything or they want the most of everything. That doesn't necessarily apply here. All we're trying to do is make sure that this engine can handle most of the horsepower goals you're going to chase.
Reliably.
Correct.
Yeah.
Okay, and basically we want it to be repeatable, so we want it to do it over and over again. Okay, so that's rotor machining. Really simple, nothing too complex, no rocket science there. The next thing we kind of do to make the engine a little more rugged, we're going to do something called dowelling. Okay, now what dowelling is if you look at these holes in the corner here, so I'll move this rotor housing. So there's one hole down the bottom here and one hole up the top here. These are what Mazda put as dowels to stop the engine from twisting away from the rotor housing. Okay, yeah, cool, thank you. So basically, that slides into there and locks in, let's bring the rotor housing, locks into this hole on the rotor housing. So if you didn't have these, each part will twist off itself, essentially. All right, so you need something to locate the whole engine together. We basically go through and machine 4 extra holes on the face of this iron, and we add 4 more of these. Okay, and the idea is we're trying to stop the plate from breaking. Now, what's common on these is we tend to see, so Mazda put the dowels over here, we tend to see this part here crack. Adding a couple of these tends to take the weight off this corner here and spread the load across the rest of the plate, and it gives you another 100, 150 horsepower worth of headroom if you like. Now, obviously, it doesn't make it bulletproof because when you move the weak point from here, it just moves it somewhere else. So what we tend to find, once you dowel an engine, the next point of breakage is down the gear area. Yeah. Okay, and there's nothing that we can really do in this area to kind of make it stronger. Obviously, when you kind of get to that level, you go to a billet plate. Okay, that's pretty much it, really. So, I mean, we've spoken about balancing, we've spoken about porting, and we've spoken about dowelling. Yeah. Okay, so I mean, it sounds really simple, but it's a really basic recipe to end up with an engine that can reliably produce 600 horsepower all day long.
So now we have a new engine being built. For my viewers and also for me, what kind of preventative maintenance would you do to make sure that doesn't happen again? Okay,
so there's two sides to that question. So the first one is really basic, okay? I mean, anyone who kind of does a little bit of work on their own car, or whether they send it to a shop or not, we've got to do basic maintenance. Make sure that your coolant's always being, checked and changed.
And how regularly would you say that would be?
Look, I would say coolant at least once a year.
Wow.
Okay. Look, you have to remember that you're dealing with an engine with different materials in it, and everything corrodes at a different rate, and coolant doesn't last forever. Okay. So coolant's heavily affected by weather as well, and I mean, in Australia we get wild changes in weather. And again, basic servicing, oils, fuel filters, really, really simple stuff. I know it almost seems stupid enough just to say it, but you'll be surprised as to how many people miss it. So that's one aspect. Second aspect, and we've spoken about it before, is engine protection. I think that's one of the best forms of preventive maintenance. At the end of the day, if you have all that stuff set up and working, then you can prevent overheating scenarios, fuel surges, lean outs, oil starvation. I mean, they're the most common causes of engine failure.
Yeah.
So, I mean, the way I think about it, if this engine didn't fail from a coolant seal, one day it would have failed from a fuel starve. Okay, and if you pushed it hard enough to track, it would have been an oil starve. And with the Apexif RFC, you would never know. Look, honestly, it really is that simple.
Yeah.
There's no magic to it. It really just is that simple. So follow those items, and it really is pretty smooth sailing.
Yeah, awesome.
Alrighty.
Well, thank you, Omar.
No
it was a
worries.
pleasure. We spent a lot of
same.
time on that video, and honestly, he's been very generous with his time. So thank you, Omar, very much.
That's cool, man. It's good fun.